Assalamu alaikum students. How are you? So I suppose all of you are fine. Alhamdulillah. So today we are discussing differentiation topic for IGCSE Mathematics 0580. Some students are confused, sir, this topic is not included in O levels. Some students basically compare the topics from 4024, that's O levels. So in O levels we don't have any topic differentiation. Okay, so let's say we have a graph and I want to calculate the gradient of any point. So let's say this is some point x1 y1 or any point xy. So actually what we do, we take out any 2 points from that tangent which are actually not on the curve. We take out any 2 points, let's say x1 y1 and x2 y2, and then I would take out the gradient by using y2 minus y1 over x2 minus x1. That's quite easy. But the problem arises when we don't have any curve with us. So the problem arises. So what happens when we don't have a curve? So let's say we have a curve and we can clearly see that it has different patterns at different points. So let's say if I want to take out the gradient at this point, that is going to be a different one. So let's say if I am going to take out the gradient at this point, that is going to be another different one. Okay, so I will draw a tangent at that point. If I want to calculate the gradient of any particular point of the curve, I will draw a tangent on that point. So by the pattern of that tangent, I will find out the pattern of my curve. So let's say I have different points. This point is A, this point is B, this is C, this is D, this is E, and this is F. So at different points I have different patterns. So A, B, C, D, E, F. So you can clearly see that at point A my curve is basically increasing, and at B again it's increasing, but at C I would say it's neither increase nor decrease. Okay, what about D? At D it's decreasing. At E again it's neither increasing nor decreasing. Okay, what about point F? Again it's increasing. So we can clearly see that we have different patterns at different points. So now the problem arises. What is the problem? We don't have any 2 points. We don't have a curve. If I want to calculate the gradient of, let's say this is a curve, and I want to calculate a gradient of this line. So I have 2 points. So this point is x1 y1, this point is x2 y2, and that's very simple. We call it secant line or secant line. So let's say this is a secant line. So the gradient of secant line is simple, y2 minus y1 over x2 minus x1. So now the problem arises when we have a tangent. So tangent has only one point, that is x1 y1 only, or I would suggest to write only xy. So if I want to make a secant line into a tangent line, so you can see we had 2 points on the curve and tangent has only 1 point on the curve. To make this process happen, we are going to close them. We are going to take x1 and x2 very close to each other. So I would say that x1 is nearly equal. X1 is nearly equal to x2 and y1 is nearly equal to y2. So for that purpose, I would say there is a term lim. Lim means limit. So that is not in your syllabus, but I would just I'm just giving you a concept. So I would say that x1 tends to x2, and the gradient remains the same. That is y2 minus y1 over x2 minus x1. So basically, what is delta x? Delta x is basically change in x, that x2 minus x1. What is delta y? That is y2 minus y1. So if two values, that is x1 and x2, are very close to each other, then I would say that the change in x is almost 0. So I may write it like this as well. LIM, change in x is almost 0 because x1 and x2 are very next to each other. Okay, and this thing is written as delta y over delta x. So delta is representing the change, and this is going to be written in the form of dy over dx. That is, the short form is in this complete value. Okay, so actually, if I am going to zoom this, we have a curve, and this was supposed to be my tangent line. Let's say this is a curve, and that was supposed to be my tangent line. So what I did, actually, if I zoom it, I will draw another line which is very near to it, and you can see that this point was xy. It's only single point. I took this point on the curve, that is x1 and y1, and I took this point, that is x2 and y2, and I would say that x1 is very near, close to x2. So x1 is very near, close to x2. So if x1 and x2 are very close to each other, then I would say that the change in x is almost 0. So this complete thing, that is change in x is almost 0, it will be equals to dy over dx in the short form. So let us take an example. Let's say we have a quadratic curve. So this is our x-axis, this is our y-axis. So let's say this is x equals to 2, this is y is equals to 4. We know that. So if I'm going to ask you that my function, that is y equals x square, so I can say that x equals to 2, my y is 4. Okay, so what if I ask you that if x changes from 2 to 2.1, find the change in y. Okay, so then I'm going to say that if y is equals to x square, so my y1 should be x1 square and my y2 should be x2 square. So now y1 is basically x1. So this is value of x1. So I would write 2 squared and I would write 2.1 square. So y1 becomes 4 and y2 becomes 4.41. Let me check in the calculator. So 2.1 times 2.1, that is 4.41. So now my change in y should be 4.41 minus 4, that is 0.41. So that is basically an accurate change. So now the approximation change. Differentiation is basically used for the approximation change. So the same question again. What is the question? The question says that if y is equals to this, at x equals to this, if x changes from. So now I'm going to find out the approximate change. So for the approximate change, I would write limit x1 tends to x2, y2 minus y1 over x2 minus x1. So this is my approximate change. That is delta y over delta x. It's going to be approximately equal. That is not in your syllabus. I'm just giving you a concept. So let's say it becomes x1 tends to x2. Now my y2 is x2 square. y1 is x1 square over x2 minus x1. So the concept says that x1 is very near, x1 is very close to x2. So what if they are very close to each other? I may take x1 as x2. So if I take x1 as x2, that is going to be 0 over 0. Obviously that is not going to happen. That is a very wrong answer. So I need simplification. So what is the simplification I am going to do here? Okay. So this is going to be x2 plus x1 times x2 minus x1. That is the identity I have used here. A squared minus b squared. Now x2 minus x1 factor is common and it is going to be cancelled. So this is going to be cancelled, and now I would suggest that x1 and x2 both are same. So I would write, okay, you can see x1 and x2 were arbitrary. There was no x1 y1 x2 y2. Actually there were closer points to xy. So in actual, x1 and x2 are actually x. So what I will do, I will put x1 and x2 both as x. So it would become x plus x. So change in y over change in x becomes equals to 2x, and change in y becomes equals to 2x times change in x. Okay, so what was our x value? So x value was 2, and change in x, if we are changing from 2 to 2.1, then my change is going to be 0.1. So finally my change is 0.4. So you can clearly see that this value 0.4 and this value 0.41, obviously both are not same. That was accurate change and this is approximate change. So differentiation is used to find out the approximate changes in the curves in any scenario. Okay, and if we don't have any curve, so for that purpose we use the approximate changes. It is used to find out the gradients of tangents. Okay, so tangent has only 1 point, and for the gradient we need 2 points. So that's why we need approximation, and for approximation we are going to apply differentiation. Okay, so what if I am giving a method for which y equals x power n, and that is going to be a very generic method. So that I am going to be discussing in the next lecture. I suppose